In the previous videos we've built a model of a CPU. In this video I'm going to manually step through an assembly language program to show how a CPU works at the lowest level. So I've made two small modifications to the CPU. I've taken the control lines, which are the green lines in this diagram, and moved all the switches which are controlling the inputs and outputs to the registers and the memory and that sort of thing, all into one place. So if we look here, we have all the switches connected to the control lines, and the meaning of the switch is written in this table above. There's a few extra that we haven't implemented yet that will be implemented in future videos, and we'll add those later. I've also added an output register, which is a register with input lines only, which are connected to the bus, and the output of the register is connected to some LEDs where we can read the value of the output. So we'll use this to store values of calculations that we do in the CPU. Now I've written this short assembly language program, and we're going to go through this and manually set the control word to execute this program. So here we have three views of the CPU. At the top we can see the whole CPU model. On the bottom left we can see just the input lines and the clock, which is this area here. At the bottom right we can see just the control word, which is this area here. Now here's our assembly language program. If I just explain what each line means, so I get to basically make up this language because I'm designing the CPU. So the first line is saying move the value 15 into memory address 128. And the second line is saying move the value 5 into the address 129. Next line, load A, saying load the register A with the value at the memory location 128. The next line, add 129, means add the value at the memory location 129 to the value in the register A and put it back into register A. And finally the outline means send the result to the output register. So let's have a look at how we can run this program. So first we want to move the value 15 into memory address 128. So first we'll load 128 into the address register so that we can load a value into that address. So 128, address register in, and send a clock pulse. So now we're addressing memory address 128. Now we want to load the value 15 into it, so we put the value 15, which is 8, 4, 2 and 1, onto the bus, memory in, and send a clock pulse. So now we should have the value 15 in the memory address 128. The next instruction, move the value 5 into address 129. So first we load the 129 into the address register, the 129 on the bus, address register in, and send a clock pulse. Then we want to move the value 5 into that address. So we put the value 5 on the bus, which is 4 plus 1, ram in, and send a clock pulse. So now we've loaded the value 5 into memory address 129. Next instruction, load the value at memory address 128 into register A. So first we need to address the memory 128, address register in, send a clock pulse to address that memory. And next we want to move the value at that address into register A. So RAM out, register A in, send a clock pulse. We can see in register A the value 15 has moved from memory address 128 into register A. Then the next instruction has a few steps. We want to add the value at address 129 to register A. So we need to load the value 129 into register B, add the result in the ALU, and then take that result and put it back into register A. So first we'll address 129, so 129 on the bus, address register in, send a clock pulse. Now we're addressing memory address 129. We want to take that value and put it in the B register. So RAM out, B register in, send a clock pulse. We load the value 5 in the B register. The ALU is in add mode because the subtract switch is switched off. So now we want to take the ALU out and move it back into register A. Send a clock pulse. And that's the add 129 step. And then the output, we want to take register A out and the output register in and send a clock pulse. And now if we look at our output register, we should have completed the program where we've added the value 15 and 5, and if we look at our output register we should have the value 20, which is 16 plus 4. Now the way a machine code program actually works is there's a fetch phase and an execute phase. What we've done here is we've gone through the execute phase of the program by manually setting the control word and manually sending clock pulses to run through this program. What we'll look at next is how we can put this program into memory and how we can have the computer read this program back out and then execute the program itself. So the next step is to have the computer read this program and execute it. So we'll convert this assembly language program into machine code and save it into the RAM. Then we'll have the computer execute the program. If you've learned something from this video, give it a like, and if you'd like to follow the series, subscribe. Thanks for watching.